Okay, let's go ahead and do number 6 together. Let's read out loud. Huntington's disease is an autosomal dominant disease. The distribution for the Greek population is 18%. Determine the allelic frequency for this disease in the population. Determine the heterozygous frequency, the probability that these heterozygous individuals marrying, and the probability of these two having an affected child. Let's do the first one really quick. Let's go ahead and talk about autosomal dominant. Remember we said autosomal dominant? We're going to be talking about Hardy, Weinberg. We have dominance. So if we have dominance, we're going to say p squared plus 2pq plus q squared equals 1. And then remember we said that dominance is going to be p. So anywhere we see p is dominant. And anywhere we see q is recessive. So let's go ahead and talk about what they gave us here. They gave us the distribution is 18% is dominant. So we can say all of this equals 18%. This p squared plus 2pq. Let's go ahead and write that right here. P squared plus 2pq equals 0.18 or 18%. Okay? Now, let's go ahead and figure out what we're left with. Well, if we know this equals 18 and we know this plus q squared equals 1, we can say our q squared equals 1 minus 0.18. So if we say that, our q squared is going to be 82% or 0.82. So now we have our q squared, we have a recessive, we have our dominant. Now let's go ahead and give them what they want. They want to know the allelic frequency for this disease. They want to know the p for this disease. Since it's autosomal dominant, they want to know just the allelic frequency, they want to know p. Well, we know what p squared is, we know what q squared is. We can go ahead and give them what p equals. So we know q squared is 0.82. We can say q is the square root of that. Square root of 0.82 is going to be 0.91. So that's p. And then we're going to say this is our q. P equals 1 minus q. So we're going to go and plug that in for q. And we're going to go ahead and say p equals 0.09. So we're going to say 0.09 here is the allelic frequency for the dominant. Now, they want to know the heterozygous frequency. Let's go ahead and give them that. Heterozygous is going to be 2pq. 2pq. Well, you know p and you know q. So let's go ahead and just do 2 times that, and we should be getting a number of 0.163. So that's our heterozygous frequency. Now they want to know what is the probability of 2 of these people mating together? What's the probability of these 2 people mating together? We're going to go ahead and say this times another one of these people. So 0.163 times 0.163 is going to equal 0.027. And that's the probability of 2 of these heterozygous individuals mating. Now we want to know what's the chance that 2 heterozygous individuals are going to produce an affected offspring. Okay, and we said it's an autosomal dominant. So autosomal dominant means you have the big allele. You got to have that big allele there. This little one's recessive. So we should have this big allele present everywhere. So let's go ahead and see what we have here. We have a big R, big R, big R, little r, big R, little r, little r, little r. So I see a big R here, a big R here, and a big R here. So 3 out of the 4 kids are going to be affected. So 0.75 or 75% are going to be affected. And let's go ahead and that's how you do this problem.